Hello, everyone. Today we're going to introduce an open source large model that has made new progress in reasoning ability, DeepSeek-R1. The most striking feature of this model is that it has for the first time verified that the reasoning ability of large language models can be completely achieved through reinforcement learning. Reinforcement learning. Without the need for the traditional supervised fine-tuning, SFT process. Unlike traditional supervised fine-tuning, which requires a large amount of manually annotated high-quality data, reinforcement learning allows the model to autonomously learn the optimal reasoning strategy through continuous trial and feedback. This method not only reduces the reliance on manually annotated data, but also enables the model to develop more flexible reasoning patterns. This is the latest research achievement from the DeepSeek AI team. The DeepSeek-R1 project includes two core models, DeepSeek-R1-0 and DeepSeek-R1. Both of them adopt the mixture of experts architecture, with a total parameter count of 671 billion, and activated parameters of 37 billion, supporting a context length of 128,000 tokens. DeepSeek R1-0 is the first breakthrough achievement of the project. The research team directly applied large-scale reinforcement learning training to the base model without any supervised fine-tuning. This method allows the model to naturally form a variety of powerful reasoning behaviors, including self-verification, reflection, and generating long chains of thought processes. However, R1-0 also has some issues, such as endless repetition, poor readability, and language mixing. To address these issues, the research team developed an improved version, DeepSeek R1. This version incorporates cold start data before reinforcement learning and adopts a training process that includes 2 reinforcement learning stages and 2 supervised fine-tuning stages. Here, reinforcement learning is used to discover better reasoning patterns and align with human preferences, while supervised fine-tuning lays the foundation for the model's reasoning and non-reasoning capabilities. In terms of performance, according to the test data from the DeepSeek team, DeepSeek-R1 has shown a level comparable to OpenAI O1 in multiple benchmark tests. In the IME 2024 mathematics competition test, DeepSeek-R1 achieved a 79.8% pass at 1 score, slightly higher than OpenAI O1's 79.2%. In the Math 500 test, DeepSeek-R1 achieved an accuracy rate of 97.3%, comparable to OpenAI O1's 96.4%. That in the evaluation of coding ability, DeepSeek-R1 reached a 96.3 percentile score in the Codeforces test, basically on par with OpenAI O1's 96.6%. Additionally, in reasoning tasks such as GPQA Diamond and MMLU, DeepSeek-R1 scored 71.5% and 90.8%, respectively, although slightly lower than OpenAI O1's 75.7% and 91.8%. The gap is not significant. More notably, the research team demonstrated that the reasoning patterns of large models can be distilled into smaller models. They have open-source 6 relatively smaller models based on Llama and Quen, ranging in size from 1.5B to 70B. Among them, the performance of DeepSeek-R1 Distill Quen 32B is particularly outstanding, achieving a 94.3% accuracy rate in the Math 500 test, surpassing OpenAI O1 Mini's 90%. It also scored 72.6% in the AIME 2024 math competition test, showing an advantage over OpenAI O1 Mini's 63.6%. These results indicate that, through distillation techniques, even smaller scale models can maintain considerable reasoning capabilities. In practical applications, the temperature parameter of the model is an important setting to control the randomness of the output. The higher the temperature value, the more creative but potentially less accurate the model's responses will be. The lower the temperature value, the more conservative but reliable the responses will be. The DeepSeek team recommends setting the temperature between 0.5-0.7, recommended 0.6, as this range achieves a good balance between accuracy and creativity. Research has found that adding system prompt, can interfere with the reasoning patterns the model has already learned, reduce performance, so it is recommended to use user prompt directly for mathematical problems. It is best to include the \boxed instruction in the prompt to mark the final answer. This can make the model output the calculation results more clearly to obtain more reliable evaluation results. It is recommended to test the same problem multiple times and take the average, because the model's output has a certain degree of randomness. DeepSeek-R1 adopts the MIT license, supporting commercial use, allowing any modifications and derivative works, including model distillation. Currently, DeepSeek-R1 can be used through the chat.deepseek.com website or invoked through its OpenAI-compatible API interface, platform.deepseek.com. The significance of this project lies in the fact that it not only advances our understanding of large language model training methods, but also provides the open source community with a series of high-performance models, laying the foundation for future research and applications. Of course, there is still room for improvement in these models, such as in the handling of certain simple problems which is not yet perfect, and this is also the direction that future research needs to continue to explore.